Hey guys, Lissandro here, and I thought I would do a whiteboard blog. So I wanted to do this because of something that kind of came to mind. Not far from here, there's like a supermarket. If y'all live around the Houston area, or in Texas in general, um, here in the U.S. You'll probably know have heard of Fiesta Supermarket. There's one like not far from where I live, but anyway. So basically, going towards there, always pass by, I guess like kind of a pressure regulation station of natural gas and all, and you can usually smell the natural gas. Um, that's probably that's probably like something that they put on it, just kind of like um, scent signalers or something like that. It's just basically sent to pretty much get the scent of it. I know it contains methane and other natural hydrocarbons and other stuff like that. But anyway, that's not the point. The point is that pretty much always wonder why they have those stations and all. And the thing is that apparently, I got thinking, and in reality, this kind of makes sense. Those pressure regulation stations is that they pretty much have to pressurize the gas. And the reason why is because they have to keep it consistent. They have to keep it consistent according to a certain range depending on its use. Now let me just draw something. Okay, so let's say um, let's say there's some field here. Okay, let's say there's some field here or something like that. Okay, and pretty much here's some average dude or something like that. Just okay, some average dude here and all. And let's say all of a sudden um, he discovers um, that there's something underground. Okay, so let's say, for example, that they discover pretty much that they run some tests and pretty much they discovered that there's natural gas underground and all. Now, there's two instances in which they find um, natural gas. Now, it might be pretty much like just a containment of natural gas. Okay, I haven't looked that in depth in geology or anything like that, but based on the little bit that I know, um, there's these are pressure veins. There's just compositions over millions of years, decomposition and pressure and so on. Okay, that's one state. The other state is that either it's in combination with oil. If it's underneath, if it's underneath, uh, and they're only going for the natural gas, that's good. They just um, fixate a line. They pretty much know how to dig and pretty much fixate it, and in the sense that fixate in the sense that the pressure itself propels the gas on forward, and it just uh, flows through here and all. Okay. Now, if they're going for the oil, that's a completely different deal. It's actually the inverse. It would have to be over the natural gas, but it all depends because I'm not really in its liquid form and considering pressure and everything like that. I don't know which one has which one would be on top, and I'll also have to consider density and other stuff. But anyway, um, so let's say they get these pipelines, they drill and everything, and they send it on forward. Okay, these are distributed through pipelines. There might be some other stuff that they do, and everything to treat it like certain plants or anything like that. That I guess to kind of run it through a process or something like that, and pretty much from there they distributed to different households. But before it gets there, it runs through these stations. It runs through these minor gas stations and terminals, which from there they do distribute uh, into individual households. Okay, okay, they distribute into individual households and all. Okay, but you have to keep in mind something. There's a certain amount of pressure here. There's a certain amount of psi. Psi stands for pounds per square inch. Okay, okay, that's what psi stands for. Okay, now in regard to this certain psi and how much you get from here, how much um, psi you get from here, and how much you get uh, to every individual home. Okay, you have to consider one thing. Hold on, I'm kind of messed up here. As the fuel gets burned up, it gets used up, and as it gets used up, the psi, how much pressure goes down. It goes down. It decreases. Now, you probably might think that, oh, that's no big deal, just pumping more gas, and it's not that simple, because in order to maintain something without losing its pressure, there's a variety of things you have to consider. You have to consider how big the cross section of the pipelines are, and how long of a distance you plan to travel that gas. Now, these individual stations, I don't know what they're called, are crucially important, and it's actually a safety measure, because the thing is that when psi goes down, that's not a good sign, because here's the thing. As you're burning, as you're burning, it the fire doesn't spread into the pipeline in which it's coming from, and the reason not why it's not is because two different things. One, it needs oxygen to propel itself inside, and all you have is the fuel. You don't have the oxygen, sufficient oxygen for it to burn inside. However, um, if the pressure drops substantially, air can pretty much filter through here, and what happens is that the fire spreads into here, and it can spread through the source, and especially if the pressure drops at a substantial amount. Okay, and the reason why this is important is because uh, think of it this think of it this way. If all this principle also applies to like blow torches and stuff like that. Okay, let's say you have a rope. Let's say you have a rope that's burning. Okay, you have a you have a rope that's burning. Okay, let's say there's like fire here, and let's say you have a roll of rope that, let's say you're right here. Okay, you're right here, and you're like giving it giving it more rope, kind of like a wick. Okay, as long as you keep this rope, as long as you keep pushing the rope more on forward, the fire is not gonna catch up to you because you keep pushing the rope. But what happens when you eventually, let's say for example, run out of rope? Okay, that fire is gonna catch up to you, and it's gonna it's and if you're holding it, it's gonna burn you, and it's gonna burn all the way to the tip. It's the same here. When you ignite a gas source, it's trying to burn, and it's trying to ignite at a certain rate. As long as you're on the rate of how much gas you're receiving is higher than how fast the source of fuel is the source of the ignition is burning, you should be fine. But if it's burning faster than what you can provide it, it's eventually gonna suck up that fire, and it's gonna lead over here, and that's why these pressure stations come in, because it has to pressure it according to how much is being consumed. Because also you can't have that too much pressure. You can't have too low pressure, too high pressure either, because too much pressure is kind of like you're at the end of a water hose, and all of a sudden you get a massive surge of water. It's more than what you expect, and not to mention how much pressure each pipeline can tolerate. But so pretty much this is what the deal is with these pressure stations. Um, and if you're wondering how they look like, they pretty much look like this. Okay. So anyway, thank you guys for watching. Please like and subscribe, and I'll catch you guys next time. Bye.